All right, so today just to remind you, graphs of sine and cos.
An hour ago. It's really weird using email.
All right, so just a reminder, we did this last year, so sine, remember, is the opposite side length in that triangle. So it's this length here, and so as I move the point around, so it's measuring this distance here from the axis up to where the point is, so the y coordinate. And so as you move the point around, you get a line that looks like that, which continues both ways. All right, and of course there's a cos one as well. So cos, of course, is the horizontal. So at the moment, the length from there to there is 1, so it's plotting the point up here. So as I move that angle, so that line and that line are the same length. And so as you move around, you get that shape, which is a similar shape to the sine, but where they start is different, but they're periods. So from there to there, period, 2 pi for both of them. And again, same point there to there. 360, 2 pi, the height for both of them. The amplitude is, should call it, is 1 for both of them. Alright, so amplitude of 1. But where they start is different. So the cos 1 starts here, 0 degrees up at 1, whereas the sine 1 starts at 0 and 0. So the shape is the same. So there's a whole bunch of stuff the same. All right, so let's just write that down. So for y equals sine x, put the sine 1 up there on the board. Here it is. So sine x looks like this. All right, so 0 there. Going like that. And then if we go back the other way, and so on, so that pattern just continues. So key things that we know: the period. The period is how long before it repeats, so that's 2 pi. It's amplitude, so that's from the x-axis or the midline through to the highest point is 1. And then for sine, it starts at 0, 0. And we can use these things. We've got transformations, which we'll look at in a minute. We can use these things to then work out what our transformations will have it looking like. All right. And cos looks very similar. difference with cos is where it starts. Cos in orange. So we're starting here at 0 and 1. And so we end up with something that looks like that. And of course it continues both ways. Now, things about cos and sine is that their period for both of them is 2 pi. There's the cos one. So the period for both is 2 pi, the amplitude for both is 1, but the starting point is different. It starts at 0 and 1. Alright, so that's our standard sine and cos, and so we can transform that in some way. We did this last year. Alright, so we can change the sine or the cos in some way. So over here on this one here, so we could put a number in front of the sine, or we could have a number before that bracket with the x in it. We could have a number in that bracket, we could have a number on the end. Now each of those things will do something, so at the end, which is the A, if we change that, it changes how high, so it changes the amplitude. Amplitude 5, A is 5, so 5 sine x. So it's now up here at 5. Alright, today, alright, so that's that one. Go back to 1. We could put the number here in front of the x, the angle, and when we do that, you can see that changes again. So now if n is 3, instead of the period being 2 pi, it's now 2 pi on 3. Alright, and go back to 1. 1, not 0. Alright, so you could then have a number in here, and when you do that, you can see we've now have a translation, or a number on the end here. And when we do that again, you see we have a translation. So for today, we're going to focus on these two numbers and what these two numbers here do. Alright, so graphs of the form y equals A. Now it can be sine or cos. N X. All right, so we're just going to focus on these two and what transformations these two do, and as you've seen, they both do dilations. All right, we'll worry about those other ones in a couple of lessons' time. So the period changed when I changed this number here, the n, so that's this one. So remember when I changed that to 3, the period, instead of being 2 pi, the period was now 2 pi on 3. If I have it as 2, for example,
So the smaller the dilation, the bigger the dilation?
yeah, so it's making it smaller, isn't it? So the way we say that then is down at the end of the period then. We'd say it's 2 pi over n. Alright, so it's 2 pi divided by 2 is 1 pi. And there it is. Alright, so there's a dilation from the x-axis. So n is dilation from x-axis, and so that we can say that it's making it smaller, the factor is 1 over n. Right. Amplitude is the A, that up to 1, is this, and as I said, make it 4.5 for example. Now up here at 4.5. Now if that was negative, it's going to alright, it's negative 3, so instead of being up here, it's been reflected down, and 3 is the amplitude. Alright, so amplitude is A, and if negative, we have reflection in the x-axis. All right, our starting points haven't changed, all right? So all of those that I did, we're just focusing on these two. This point here at 0, 0 stayed there at 0, 0. It didn't change, go anywhere. It moves when you do translations, but we're not looking at translations today, just those dilations. And so a cos one.
So is A dilation from the x-axis too?
From the x-axis, yeah.
By a factor A?
Yes. I've written that wrong, haven't I? It's not right, is it? It should be y-axis for that.
Yeah, that's what I thought. I'd written the other ones and I wrote it out, and then you were like,
So we should...
So this, yeah, I wrote that wrong. N is from the y-axis because it moved it that way, didn't it? You should stop me if you think I've done something wrong.
Just don't trust myself. I don't trust
Don't
myself.
point
in
to
this.
me.
My faith in myself is.
Well, you should have trusted yourself in that case
Where
there,
is
Clint.
the amplitude? Is that negative A afterwards, or is it just equals A?
It's
It's just adding.
Is that better?
Yeah.
All right, yes, and the dilation from the x-axis, because it's doing this, isn't it? The n does this, and the a does this. So same with the cos. Here's our a. Same thing. Makes it. And then they're using b on this one. All right. So you can see again that start point here. That doesn't change.
What happens when you go to zero? Does it just go flat?
0.
It's fine, isn't it?
It's just 1.
Can you put them all to 0?
So it's just flat. Because now it's going doing the cos of 0, which is 1, isn't it? So no matter what your angle is, 0 times it's still 0. Put them all to 0.
Can you put them all to the full thing?
Now look at that. All up.
Yeah. Bye. Yeah. That's what we like to see.
Yeah, you've been silly, Lara. Right.
Is it x plus c, not x minus c?
Yeah, they write it different than what
Okay.
should be written. Yeah, what we
Just
do.
change the rules up on here, then.
Depends on who. I just get these off a GeoGebra site. So one of the things depends on who wrote the thing as to how they interpreted it. Yes, but we use minus c. All right. So starts at. So sine starts at 0, 0, and cos 0 and 1. Now, of course, if there's a dilation,
Excuse me, Mr. Sine, can you have a place to here do his work?
you can, there's a spot there.
Thank you.
So for the cos one, when you change to A, actually changes this point here, it moves that way, doesn't it? So if I go A is 2, so that's now my starting point. Instead of being 0 and 1, it's now 0 and 2, which is the A. Alright, so cos normally would start at 0 and 1, but because if there's a dilation, it starts at 0 and 8. Alright, so we can use that to help us draw some stuff, which we will do. Alright, am I right to rub this off? Alright, I'll just write that.
Dilation makes it for both sine and cos.
So the,
Sorry?
Yeah, because you've already written it just because 0.
Yeah, so if there's a dilation with sine, because this, the y value is 0, the 0 times anything is
1, 0.
0, isn't it? So that starting point for sine doesn't move unless you translate, but we're not translating today. So it's just the, because here we've got 1 times whatever our amplitude is. Alright, so let's sketch. Let's do a couple.
What are you doing?
Alright, so I'm going to sketch if we can figure out these three things, the amplitude, the period and where we start, and then we can use those to sketch. So the amplitude of this one, y equals 2 cos 2 theta is 2. Period is 2 pi over n, so in this case it's
2, sorry, pi, well, equals pi.
is pi. And where are we going to start? We're going to start at 0 and
1. No, 2.
2, right? Because we've got that amplitude, so 0 and 2. So to draw it, because it's got theta in there, your x-axis is theta, your y-axis has got to go up to 2 and -2. Period is pi, so if it's after one cycle
If you're not told you assume 1 cycle.
Hmm?
If you're not told.
If you're not told, yeah, 1 cycle. All right, so 1 cycle, starting point 0 and 2. 1 cycle later, it's going to go down and it's come back up. So it gets back up to 2. 1 period later, 1 cycle later, which is at pi. For cos, the lowest point is where? -2, and in the theta axis, it's halfway between our peaks, so it's down here. And we'll cross the axes halfway between those spots, so we'll cross the axes here and here. So there it is.
So even if it says theta, you don't have to write it in degrees.
No. The only time you have to write it in degrees is if it had a degrees up there. If it said degrees up there, then you would write it in degrees. If it doesn't, then it's radians. So no matter what symbol they use to represent the angle. All right. All right, this next one, same deal, amplitude. Period. And then the start. Right. So I'll get to this stuff in a minute. So amplitude, what's our amplitude? 3. Period, 2 pi on n. And what's n in this case?
1.
Not t, t is our variable. Ooh, that shouldn't be fx, that should be ft. My bad.
So
Again.
the period is pi.
Alright, so n in this case is pi. Alright, so it's the number in front of the variable, and the number happens to be pi. So 2 pi on pi, which is 2. And so a lot of times in application questions, you'll have your where t might represent hours, for example. Then your n will be in terms of pi. All right, and so where are we going to start? It's a sine, so we start at 0, 0. All right. Okay, so now we get to this here. So this here, the 0 and the 2, what does that tell us?
It's between 0 and 2.
Between 0 and 2, so we're going to sketch it between 0 and 2.
Including 0 and 2.
Yeah, including 0 and 2, correct. So it's telling us the domain or how much of the graph to sketch. All right, amplitude is 3, so there's 3 up here. So it's going to go down to -3. We start at 0, 0, goes up, comes down, goes back up and gets back to 0 there. So if it's gone up, it's going to cut back on the way back down through there. Halfway between is the highest point, halfway between is the lowest point. And there we are. All right, anything that I've written wrong there this time? Terrible. No, anything I need clarifying before we get started and do exercise 6D?
I think so.
Don't think so. All right, 6D then.